Hello students, in this video we will be seeing solutions for previous year NEET question paper, and we will be seeing the topic called electromagnetic induction and alternating current. So before going inside the questions, let us have a statistical analysis about the previous year question paper. So if you see this particular unit called electromagnetic induction and alternating unit, we have several subtopics. So from all these subtopics, questions were coming for the past 33 years. And if you see the percentage, for around 29% of questions were coming from Faradays laws and Lenz law, and around 2% of questions were coming from eddy current, and 10% were coming from self-induction and mutual induction, and 8% were coming from transformers, and 1% from AC generator, and 7% from alternating current, and 13% from AC circuits, and 2% from LCR series circuits, 5% from LC oscillations, and 16% from power in AC circuits, and 7% from resonance. So if you just have a look, the majority of questions were coming from Faraday's law and Lenz law. Around 30% of questions were coming, and next to that, power in AC circuits, 16% of questions were coming, and AC circuits, if you see, around 13% of questions were coming, and in self-induction, mutual induction, around 10% of questions were coming, and rest of the topics, if you see, less than 10% of questions were coming for the past 33 years. So this was the scenario for the past 33 years, and if you have a look at the past 8 years, the majority of questions were coming from again Faraday law and Lenz law. Around 36% of questions were coming from them, and around 18% of questions were coming from AC circuits, and 21% of questions were coming from power and AC circuits. So if you just see the trend, again similar topics were repeatedly questions were coming. So from Faraday's law, AC circuits and power in AC circuits, the majority of questions were coming. So if you just add out, it is more than around 70% of questions were coming from these three topics. And from other topics, less than 10% or less than 5% of questions were only coming in the past 8 years. So if you concentrate more on these topics, you will be able to solve the majority of problems from this particular unit called electromagnetic induction and alternating current. So we will try to solve questions from all the topics, and we will see some sample problems like which was asked in the previous year question papers. So let us now move on to the first question. A wheel with 20 metallic spokes, each 1 meter long, is rotated with the speed of 120 rpm in a plane perpendicular to a magnetic field of 0.4 G. Okay, it's Gauss, 0.4 Gauss. The induced EMF between the axle and the rim of the wheel will be. So here they are given you to take the 1 Gauss as 10 power minus 4 Tesla. Okay, so here induced EMF between the axle and the rim is given by E is equal to B omega L by 2. Okay, so here they have given you the B value. B value is 0.4 Gauss, and they have given you the L value also, so which is 1 meter, so it will be 1, and omega they have given you, it is 120 rpm. Okay, so rotations per minute means you know that omega will be 2 pi into r. Okay, that rotations per minute, so it will be 2 pi into 120 divided by 60. Okay, the number of rotations per minute. So this will be, you are going to substitute here. So E will be 1 by 2 into 0.4 into 10 power minus 4, because you are converting that Gauss into Tesla, into 2 pi into 120 by 60 into 1 square. So if you solve this, you will be getting it as E equal to 2.51 minus 4 volt. Okay, so the correct answer is option number B, 2.51 into 10 power minus 4 volt. So the induced EMF value is 2.51 into 10 power minus 4 volt. So it's a very simple direct question. Just you are going to make use of the formula B omega L by 2, and you are going to substitute the values whatever they are given. Okay. Let us now move on to the next question. The magnetic flux linked with a coil in Weber is given in equation pi equal to 5t square plus 3t plus 16. The magnitude of induced EMF in the coil at the 4th second will be. Okay. So, here the magnitude of the induced EMF, the magnitude of induced EMF is given by d pi b by dt. Okay. So, you are going to just differentiate this d by dt of 5t square plus 3t plus 16. So, if you differentiate with respect to t, you will be getting it as 10t plus 3 plus 0. Okay. So, this will be 10t plus 3, and they are asking us at the 4th second. So, t will be equal to 4. So, the magnitude of EMF will be 43 volt. Okay. Because here instead of t you are going to substitute 4. So, 4 into 10 40 plus 3 43 volts. So, the correct answer is option number C. Okay. It is also a very simple question. Just you are going to substitute the formula and you are just going to differentiate the equation what they have given. Okay. The magnetic flux equation what they have given, you are going to differentiate and you will be getting the magnitude of the induced EMF. Okay. Let us now move on to the next question. A cycle wheel of radius 0.5 meter is rotated with constant angular velocity of 10 radians per second in a region of magnetic field of 0.1 Tesla, which is perpendicular to the plane of the wheel. The EMF generated between the center of the wheel, the EMF generated between its center and the rim is. Okay. So, for a wheel rotating about an axis passing through its center and perpendicular to the plane of the wheel, the EMF will be E is equal to B omega r square by 2. Okay. So, here they have given you the angular velocity as 10 and magnetic field is 0.1 Tesla and the radius is 0.5. So, you know all the values, you are just going to substitute that is all. So, you are going to put magnetic field as 0.1 and this angular velocity as 10 and radius is 0.5 the whole square divided by 2. So, if you solve this, you will be getting it as 0.125 volt. Okay. So, here they are asking us to calculate the EMF generated between the center and the rim. So, which is around 0.125 volt. So, the correct answer is option number C. Okay. Let us now see the next question. A 800 turn coil of effective area 0.05 meter square is kept perpendicular to a magnetic field 5 into 10 power minus 5 Tesla. When the plane of the coil is rotated by 90 degrees around any of its coplanar axis in 0.1 second, the EMF induced in the coil will be. Okay. So, here given that coil is kept perpendicular to the magnetic field, B is equal to 5 into 10 power minus 5 Tesla. So, the angle between the area vector A and magnetic field B is theta, which is equal to 0 degrees. So, the EMF induced will be E is equal to N into d pi by dt. Okay. So, which is equal to N into BA cos theta by dt. And here they have given you the magnetic field as 5 into 10 power minus 5 and the effective turn N is 0.05. Okay, sorry, N is 800. So, 800 into the magnetic field is 5 into 10 power minus 5 into the effective area A is 0.05 and theta is equal to 0 degrees. So, cos 0 will be 1 divided by dt, which is 0.1. So, if you solve this, you will be getting it as around 0.02 volt. Okay, so here they have said that the coil is kept perpendicular to the magnetic field B, which is equal to 5 into 10 power minus 5. So the angle between the area vector and the magnetic field will be 0 degrees. So theta value will be 0 degrees. That's what we have arrived. So just you are going to substitute the values and you will be getting the final induced EMF as 0.02 volt. So the correct answer is option number B. Okay. Let us now move on to the next question. A long solenoid of diameter 0.1 meter has 2 into 10 power 4 turns per meter. At the center of the solenoid, a coil of 100 turns and radius 0.01 meter is placed with its axis coinciding with the solenoid axis. The current in the solenoid reduces at a constant rate to 0 amperes from 4 amperes in 0.05 seconds. If the resistance of the coil is 10 pi square omega, the total charge flowing through the coil during this time is 16 microcoulombs, 32 microcoulombs, 16 pi microcoulombs, 32 pi microcoulombs. So we have to find out what is the total charge flowing through the coil during the time. So here Q is given by del pi by R. Okay, so initially what happens is the current is 4 amperes. Okay, that's what they are given, 4 amperes. So B1 will be mu naught N I. Okay, so it is 4 pi 10 power minus 7 into 2 into 10 power 4 into 4. Why this 2 into 10 power 4 is the number of turns, N value. So if you solve this, you will be getting 32 pi to 10 power minus 3 Tesla. So this is B1 and pi 1 is N B1A. Okay, so it will be 100 turns. Here they are giving you 100 turns into 32 pi 10 power minus 3 into pi r square. Okay, so pi into r square 0.01, that is the area. So you are substituting it here. So if you solve this, you will be getting 32 pi square into 10 power minus 5 Weber. Okay, so as the current reduces to 0 amperes, B2 will be equal to pi 2 equal to 0. So B2 and pi 2 will be equal to 0 because it is reducing from 4 amperes to 0. Okay, since the current is reducing, so B2 and pi 2 will be equivalent to 0. And we know that Q is equal to del pi. Del pi means it is pi 2 minus pi 1 by R. Okay, so you know what is pi 1 is, just you are going to substitute and find out what is Q is. So it is 32 pi square into 10 power minus 5 divided by 10 pi square. Okay, what is R is, we are finding out R as 10 into pi square. So here they are given you the resistance of the coil is 10 pi square ohm. So that's what we are substituting here. Pi square and pi square will get cancelled and this 10 will go to the numerator and it will be 32 into 10 power minus 6 or 32 microcoulomb. The Q value is 32 microcoulomb. Okay, so the correct answer is option number B. Okay, so just this is also a mere substitution of the formula, but we are taking two conditions. Initially the current is 4 amperes and afterwards it reduces to 0 amperes. So you are finding out what is the pi 1 and pi 2 value. So pi 2 is 0 and since it is a modulus, it will be a positive value, and finally you are calculating the total charge flowing through the coil, which is around 32 microcoulomb. Okay, so this is microcoulomb. Okay, let us now move on to the next question. In which of the following devices the eddy current is not used? Okay, so if you see eddy current relies on the magnetic induction. Okay, so here if you see electromagnets, they rely on the eddy current, or you can eddy current effect is being used. In induction furnace also it is being used, and magnetic braking train it is being used. So the only place where this device which doesn't use this eddy current effect is electric heater. So the correct answer is option number B. Okay, it's a direct simple question. The only place where the eddy current effect is not used is electric heaters. Okay. Okay, let us now move on to the next question. A long solenoid has 1000 turns. When a current of 4 amperes flows through it, the magnetic flux linked within each turn of the solenoid is 4 into 10 power minus 3 Weber. The self-inductance of the solenoid is. Okay, so here they have given you the number of turns N as 1000. Okay, so the number of turns is 1000 and the current flowing I is 4 amperes. I is equal to 4 amperes. Okay, and the pi value, the flux linked, they have given it as 4 into 10 power minus 3 Weber. Okay, so they want us to find out the self induction of the coil. So first find out what is the total magnetic flux linked with the solenoid. So total magnetic flux linked with the solenoid is N pi. Okay, and total flux is L into I. So the self inductance L equal to N pi by I. So you know what is N is? N is 1000 into 4 into 10 power minus 3 divided by 4. So when you solve this, L will be equal to 1 H. Okay, 1 Henry. So the correct answer is option number B. Okay. So it is just a direct substitution of the formula, all the values they have given. Just you are going to find out the total magnetic flux linked with the solenoid, which is equal to N into pi. And we know that self induction equal to total magnetic flux, it's a ratio of the total magnetic flux linked with the solenoid to the current passing through it. So you are just substituting the current value and you will be getting it as N into pi by I. You are just substituting and you will be getting the L value as 1 Henry. Okay. Let us now move on to the next question. A long solenoid has 500 turns. When a current of 2 ampere is passed through it, the resulting magnetic flux linked with each of the solenoid is 4 into 10 power minus 3 Weber. The self inductance of the solenoid is 1 Henry, 4 Henry, 2.5 Henry and 2 Henry. So this is also a similar kind of a problem. We are going to make use of the same formula. L is equal to N pi by I. Okay, so here they have given you the N value, which is 500, and they have told you the pi value, which is 4 into 10 power minus 3, and I value is 2, and you want to find out the inductance. L equal to 1000, okay, into, sorry, it's 500 into 4 into 10 power minus 3, okay, divided by 2. So if you solve this, you will be getting it as 1 Henry. So the correct answer is option number A. Okay, we are just making use of the similar formula which we have used in the earlier problem to find out the self inductance. L equal to N pi by I, and they have given you the N value and they have given you the pi value and they have given you the I value. Just substituting and you are going to find out what is the self inductance, which is equal to 1 Henry. Okay, let us now move on to the next question. A transformer having efficiency of 90% is working on 200 volt and 3 kilowatts power supply. If the current in the secondary coil is 6 amperes, the voltage across the secondary coil and the current in the primary coil respectively are. Okay. So here the power output is given by the input power into efficiency. Okay, or we can write it in a different way. Efficiency is equal to power output by power input. Okay, so here they are telling that you are having a power supply input power as 3 kilowatt. Okay, so 3 into efficiency is 90%, so it is 90 divided by 100. Okay, so you will be getting it as 2.7 kilowatt. Okay, now they are saying the secondary coil current IS is equal to 6 amperes. So ES will be P out by IS. Okay, so it is 2.7 into 10 power 3 divided by 6, so which is equal to 450 volt. So what is this? Is the voltage across the secondary coil is 450 volt. Now what you have to find out? You have to find out the current. So IP is equal to Pn by EP. Okay, so which is equal to 3 into 10 power 3 divided by 200. Okay, so the input power is 3 kilowatt, so you are substituting that, and EP value is 200, so that you are substituting, and if you solve this you will be getting the IP value as 15 amperes. Okay, so the voltage is 450 volt and the current is 15 amperes. So the correct answer is option number B. Okay, so it is just a mere substitution of the formula. Let us now see the next question. A 220 volt input is supplied to transformer. The output circuit draws a current of 2 ampere at 440 volts. If the efficiency of the transformer is 80%, the current drawn by the primary windings of the transformer is. Okay, so here again the efficiency is given by, efficiency is P out by Pn. Okay, so it is equal to ES IS by EP IP, which is equal to 0.8, because 80% means it is 0.8. And here you want to calculate how much current is drawn by the primary winding. Okay, so IP you have to find out. So IP is equal to 440 into 440 is what? The voltage, okay, over here. So 440 into 2, the current 2 ampere, divided by 220, that is this one here. Okay, EP is 220 into 0.8. Okay, so if you solve this you will be getting the primary winding current as 5 amperes. So the correct answer is option number A. Okay, it's a very simple question where you are using the formula of the efficiency P out by Pn, which is equal to ES IS EP into IP. Okay, so you know the values of ES IS EP and efficiency, you have to find out what is the current drawn by the primary winding by the transformer. So it is 5 amperes. Okay, let us now move on to the next question. The primary and secondary coils of a transformer have 50 and 1500 turns respectively. If the magnetic flux pi linked with the primary coil is given by pi is equal to pi naught plus 4t, where pi is in Webers, t is time in seconds and pi naught is constant, the output voltage across the secondary coil is. So here you are using ES by EP is equal to NS by NP. Okay, so it is 1500 divided by 50, because 1500 turns over here in the secondary coil and 50 turns in the primary coil. Okay, so you will be getting ES is equal to 30 EP. Okay, 1500 by 50 is 30, so you will be getting that. Now modulus of EP is equal to d pi by dt, so which is equal to 4 volt, because here you are having pi is equal to pi naught plus 4t. So if you differentiate this equation, this term will become 0 and this will become 4. So that's what we are getting here. Now ES is equal to 30 into 4, so which is equal to 120 volt. So the secondary coil EMF will be, the secondary coil output voltage will be 120 volt. So the correct answer is option number B. Okay. So let us now move to the next question. In a region of uniform magnetic induction B is equal to 10 power minus 2 Tesla, a circular coil of radius 30 centimeter and resistance pi square ohm is rotated about an axis which is perpendicular to the direction of B and which forms the diameter of the coil. If the coil rotates at 200 rotations per minute, the amplitude of the alternating current induced in the coil is. Okay, so here you are going to use I naught is equal to E naught by R, so which is equal to omega NBA by R, so which is equal to 2 pi F NB into pi R square divided by R. So you are going to substitute the values. 2 pi into F is 200 rotations per minute. Okay, so it is 200 divided by 60 into N is 1 into B value is 10 power minus 2 into pi, and the radius is 30 centimeter, which is 0.3 meters. So 0.3 divided by the resistance, which is pi square. Okay, they have given it as pi square. So when you solve this, you will be getting the I naught value as 6 into 10 power minus 3 Armstrong. Okay, or you can write it as 6 milliamperes, not Armstrong, it is amperes, milliamperes. So the current value is 6 milliamperes. The correct answer is option number C. Okay. So here you are just making use of the formula I naught equal to E naught by R, and which is equal to omega NBA by R, and you know omega is 2 pi F. So 2 pi into the number of the rotations. Okay, so it is 200 rotations per minute, so it is 200 by 60, and finally you are getting it as NB into pi R square, and you are substituting the values of that. Okay, so the final value of the current is 6 milliamperes. Let us now move on to the next question. A coil has resistance 30 ohm and inductive reactance 20 ohm at 50 hertz frequency. If an AC source of 200 volt and 100 hertz is connected across the coil, the current in the coil will be. Okay. So here for omega equal to 2 pi F. So it is frequency they are giving it as 50 hertz. So you will be having it as 2 pi into 50. Okay. So 2 pi into 50, and the inductance or XL will be equal to omega L, which is equal to 20 ohm. When omega dash, like when the frequency, if an like another it's increasing or something, you will be having omega dash equal to 2 pi F dash. Okay, so it is 2 pi into 100. Okay, so you are changing the source which is having a frequency of 100 hertz. You will be having omega dash equal to 2 into omega, because 2 pi into 50 is omega, so 2 into 2 omega. So you will be having XL dash is equal to 2 into L, which is equal to 40 ohm. Okay, so here I will be given by I is equal to 200 divided by Z, and it is equal to 200 divided by root of R square plus XL dash the whole square. Okay, so it is equal to 200 divided by root of 30 square plus 40 square. So if you solve this, you will be getting the current value as 4 ampere. Okay, so the correct answer is option number C. So the current in the coil will be 4 amperes. Okay. So let us now move on to the next question. A light bulb and an inductor coil are connected to an AC source through a key as shown in the figure below. The key is closed and after some time an iron rod is inserted into the interior of the inductor. The glow of the light bulb will increase, decrease, remains unchanged and will fluctuate. Okay. So here what happens is when you are trying to insert an iron rod in an inductor, the inductance will increase. So if its inductance is increasing, the impedance value also will be increasing, because Z is equal to root of R square plus omega L the whole square. So here if the Z is increasing, automatically the inductance also will increase. So since the inductance is increasing, what will happen is like I will be equal to V by Z. Okay. So the current will decrease. Okay. Since the impedance is increasing, since current is inversely proportional to the impedance, what happens is when impedance is increasing, the current will decrease, and when current is decreasing, the glow of the bulb also will decrease. So the correct answer is option number B. Okay. So it's a very simple logic problem, where when you are trying to insert iron rod in the inductor, the inductance of the inductance will increase, and when inductance is increasing, automatically the impedance value will increase, and since the impedance value is increasing, the current value will decrease. Okay. Since the current is decreasing, the glow of the light bulb also will decrease. So the correct answer is option number B. Okay. Let us now see the next question. A 40 microfarad capacitor is connected to a 200 volt 50 hertz AC supply. The RMS value of the current in that circuit is nearly equal to. Okay. So here I RMS is equal to E RMS by XC. So it will be E RMS into 2 pi FC. So which is equal to 200. That's what they are given you, the voltage EMF or something, into 2 pi into 50, frequency is 50, into the capacitance is 40 into 10 power minus 6, because it is 40 microfarad. So if you solve this, you will be getting the current value as 2.51 in 2.51 amperes. Okay. So the correct answer is option number B, 2.5 amperes. Okay. Let us now move on to the next question. A circuit when connected to an AC source of 12 volts gives a current of 0.2 amperes. The same circuit when connected to a DC source of 12 volt gives a current of 0.4 amperes. The circuit is, so here they are saying whether the circuit is series LCR, series LR, or series RC, or series LC. Okay. So here for an AC circuit, what happens is the current I will be equal to V by Z. So it is V by root of R square plus XL minus XC the whole square. So which is equal to 0.2 amperes. So when they are connected to DC source, if the capacitor is present in the circuit, it will provide infinite resistance to the current, and the current in the circuit will also be 0. However, the current in the circuit changes to 0.4 amperes. Okay. So this implies that the circuit does not contain any capacitor. So as the current in the circuit increases after connecting the DC source, the circuit must contain an inductor. So thus the circuit must be having a series of LR circuit. Okay. So the correct answer is option number B. Okay. Because when a DC source is connected, the capacitors present in the circuit will provide infinite resistance to the current, and the current in the circuit will be 0. However, if the current in the circuit will be 0, the current and the circuit changes to 0.4 amperes. That's what they have given, 0.4 amperes it is changing. So it implies that the circuit does not contain any capacitor, because if it is having a capacitor, the current in the circuit should be 0, but there is a current of around 0.4 amperes. So as the current is increasing after connecting the DC, there should be an inductance inside. So inductor must be there. So the circuit should contain a series of LR circuit. Okay, it's a very simple question, just making use of the logic. Let us now move on to the next question. Figure shows a circuit that contains 3 identical resistors with resistance R equal to 9 ohm each, 2 identical inductors with inductance L equal to 2 mH. Okay, so it is millihenry each, and an ideal battery with EMF E equal to 18 volt. The current I through the battery just after the switch closed is. So here the pure capacitor does not allow direct current and pure inductor has no effect on direct current. So at t equal to 0 there will be no effect of direct current, and you are having a circuit like this. Okay, so you have this inductance over here, so R, and this is I1, this is I1, and you are having R, and E is equal to I. Okay, so here E is equal to I1 R, and I1 is equal to E by R, so which is equal to 18 by 9, because they have given you the E value is 18 and R value is 9. So which is equal to the current flowing through the circuit is 2 ampere. Now current through the battery is given by I is equal to 2 I1. Okay, so after the switch is closed, so it will become 4 ampere. 2 into 2 it is 4. Now you are not, like, capacitor is not specified in the question, so we need to neglect the effect of the capacitor, and we will be considering it as a open circuit. So the only effective resistance on the circuit will be like this. Okay, so we are ignoring the capacitor since it is not mentioned in the question. So you will be having it as like this, I1. So according to Ohm's law, we know that E is equal to IR, or I is equal to E by R. So if you solve this, you will be getting it as 2 ampere. Okay, you know E value is 18 and R value is 9, so you are just substituting it, you will be getting it as 2 amperes. So the correct answer is option number B. So the current through the battery after the switch is being closed is 2 amperes. Okay, let us now move on to the next question. In the given circuit, the reading of voltmeter V1 and V2 are 300 volts each. The reading of the voltmeter V3 and ammeter are respectively. So they want us to calculate what is the reading of the ammeter and voltmeter. Okay, so here they are given you V is equal to root of VR square plus VL minus VC the whole square. So which is equal to 220 volt. So VR is equal to 220 volt and VL is equal to VC. So they want us to find out what is the current. I is equal to V by R. So 220 divided by 100. So this will be 2.2 amperes. So the current, sorry, the voltage is 220 volts and the current is 2.2 amperes. So the correct answer is option number B, where the voltage is 220 volts and the current is 2.2 amperes. Okay, let us now move on to the next question. The magnetic potential energy stored in certain inductor is 25 millijoules. When the current in the inductor is 60 milliamperes, the inductor is of inductance how much? Okay, so we want to find out the inductance. So here the energy stored in the inductor is given by E is equal to half L I square. Okay, so L will be is equal to 2E by I square. So you know what is the value of E? 2 into 25, the energy is 25 into 10 power minus 3 millijoule they have given, divided by the current which is 60 milliamperes, so 10 power minus 3. So if you solve this, you will be getting the L value as 13.89 Henry. Okay, so the correct answer is option number D, 13.89. Okay, so it's just a direct substitution of the formula by making use of the energy of the inductor formula. E is equal to half L I square. So you are substituting with that and you are finding out the inductance value is 13.89. Okay, so let us now move on to the next question. A series LCR circuit is connected to an AC voltage source. When L is removed from the circuit, the phase difference between current and voltage is pi by 3. If instead C is removed from the circuit, the phase difference is again pi by 3 between current and voltage. The power factor of the circuit is. So here when L is removed for RC, what happens is pi RC will be pi by 3 and tan pi will be tan pi by 3 equal to XC by R. So XC will be R tan pi by 3 which is equal to root 3 R. So similarly when you are doing it for when you are removing the C, so when C is removed for RL part, what happens is it will be pi RL is equal to pi by 3 and tan pi is equal to tan pi by 3 which is equal to XL by R. So XL will be R tan pi by 3 which is equal to root 3 R. Okay. So for an series of LCR circuit, what happens is tan pi will be XL minus XC by R. Okay. So pi will be equal to 0 because XL is root 3 R and XC is also XL is root 3 R and XC is also root 3 R. So both will get cancelled with each other and it will become 0. So pi equal to 0 means power factor cos pi will be 1. Okay. So the power factor will be equal to cos pi, so which will be equal to 1. Since pi is 0, cos 0 will be 1. So the correct answer is option number B. It is 1. Okay. So let us now move on to the next question. An inductor of 20 millihenry, a capacitor 100 microfarad and a resistor 50 ohms are connected in series across a source of EMF V is equal to 10 sin 314t. The power loss in the circuit is. Okay. So here what they have given is they have given you the L value as 20 millihenry. So inductance value is 20 into 10 power minus 3. Okay. And they have given you the C value as 100 microfarad and R value as 50 ohms and V value as 10 sin 314t. Okay. So we know that V is equal to V naught sin omega t. So if you compare these two equations, you can like these two equations if you compare, you will be getting the omega value as 314 and V naught value as 10 volt. Okay. So now you can find out the inductive reactance XL is equal to omega L. So which is equal to 314 into 20 into 10 power minus 3. So you will be getting this as 6.28 ohm. Okay. Now this is the inductive reactance. Now you are going to find out the capacitive reactance Xc, which is equal to 1 by omega c. Okay, so it is nothing but 1 by 314 into 100 into 10 power minus 6. So if you solve this, you will be getting it as 31.85 ohm. Okay, so the capacitive reactance is 31.85 ohms. Now you want to find out what is the impedances. Okay, so Z square is equal to R square plus XL minus XC the whole square. So Z square is equal to 50 square plus 6.28 minus 31.85 the whole square. So if you solve this, Z square will be 3154 ohm. Okay, so you know what is the R square is, they have given it as 50 ohms, that's what we have written here, and XL value you know you have calculated to 6.28 and XC is 31.85. so if you substitute and if you solve this, you will be getting the Z square value as 3154 and the average power PAV will be V square RMS R by Z square. Okay, so which is equal to V naught square by 2Z square into R. So V naught is 100 into R is 50 divided by 2 into 3154. So if you solve this, you will be getting the average power as 0.79 watts. Okay, so just it's a simple mathematical substitution, you are just substituting it and you have to just solve it. Take the ratio of this, you will be getting it as 0.79 watt. So the correct answer is option number A. So the power loss is around 0.79 watt. Okay, so it's a quite a lengthy problem. First what we are doing is we are making use of the equation what they have given, V is equal to 10 power sine 10 sine 314t, and you are finding out what is the V naught and omega value, because the general equation for V is equal to V naught sine omega t. So first you are calculating what is the inductive reactance, and second you are calculating what is the capacitive reactance, and then you are substituting it in the formula of the impedance Z square equal to R square plus XL minus XC square. So finally you are calculating the impedance. After calculating the impedance, you are making use of the impedance value in the power formula, and you are finding out the average power, which is equal to 0.79 watt. Okay, so let us now move on to the next question. The potential differences across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in an LCR circuit. The power factor of this circuit is, so the power factor is cos pi is equal to R by Z. So here as the current is remaining same, we can write it as cos pi is equal to R by Z, which is equal to VR by root of VR the whole square plus VL minus VC the whole square. So if you solve this, you will be getting it as 80 by root of 80 square plus 60 square. Okay, so when you solve this, you will be getting the power factor as 0.8. Okay, so the power factor is 0.8. The correct answer is option number D. Okay, so just it is the ratio of the resistance R and it is divided with Z. So it will be equal to VR by VR square plus VL minus VC square. So you know what is the values of VR and what is the value of VL and VC. You are just substituting and you are finding it as 0.8. Okay, so let us now move on to the next question. An inductor 20 millihenry, a capacitor 50 microfarad and a resistor 40 ohms are connected in series across a source of EMF V equal to 10 sin 340 t. The power loss in the circuit is, okay, so here they want us to find out the value of power lost. So we all know, like from the previous questions, P is equal to V square RMS by Z, which is equal to cos pi, which is equal to V square RMS by Z into R by Z. So P will be equal to V naught square R by 2Z square, and V naught is equal to 10 volt, omega is equal to 340 radians per second, and L is equal to 20 millihenry. And they have also given you the C value. C value is 50 microfarad and R value is 40 ohms. Okay. So we know that Z is equal to root of R square plus XL minus XC the whole square. So XL is equal to omega L, which is equal to 340 into 20 into 10 power minus 3. So if you solve this, it will be 6.8 ohm. So we have found out the XL value. A similar one like what we did for the previous problem. Okay. So first we will be finding out what is the inductive reactance, and then second thing we will be finding out the capacitive reactance, and we will be putting it in the formula of P. Okay. Same way you are going to do. So now you have already calculated the inductive reactance. Now you are going to find out what is the capacitive reactance. So XC is equal to 1 by omega C. Okay. So omega is 340 and C is 50 microfarad. So it will be 1 by 340 into 50 into 10 power minus 6. So if you solve this, you will be getting it as 58.8 ohm. Okay. Now you know what is Z square is. Z square is equal to 40 square plus 6.8 minus 58.8 the whole square. So which is equal to 4304 ohm square. Okay. So just you are using Z square equal to, you know the formula, same formula, the R square plus XL minus XC the whole square. So R is 40, that is what they have given here. XL is 6.8, which you have found it here, and XC is 58.8, you are substituting, and you are finding out what is Z square is. So Z square is 4304 ohm square. Now you are going to just substitute it in the formula. P is equal to 10 square by 2. So this formula V square by Z, you are going to use that same formula. So instead of V square by 2, you are going to put it as V naught square by 2 into Z. Okay. So 2 into 434. So this is Z square. Okay. So 434. So if you solve this, you will be getting the P value as 0.46 watt. Okay. So the correct answer is approximately this 0.46 is near to 0.51. So the correct answer is option number C. Okay. It's a similar way where first you are going to find out what is the inductive reactance, and second you are going to find out what is the capacitive reactance, and then you are going to find out what is the average power. So you will be having the average power as P average equal to V naught square R by 2 Z square. So you are going to find out all the values individually and you are going to substitute. Okay. So first finding out the inductive reactance, then capacitive reactance, and then finding out the impedance, and you are going to substitute in the formula for the power. So it's a similar problem like what we did in the previous one. The same way you are going to approach this. Okay. This is also a quite lengthy problem, but when you know the logic easily, you can easily substitute the values and you can find out. Okay. Let us now move on to the next question. Which of the following combinations should be selected for better tuning of an LCR circuit used for communication? Okay. So here they have given you 4 different combinations in which you are having the resistance, inductance and capacitance, and they are asking us which will be better tuning of an LCR circuit. So we know that quality factor of the circuit plays the better tuning will be based on the quality factor of the circuit, and for better tuning you should have a very high quality factor, and the quality factor is defined by Q is equal to 1 by R root of L by C. Okay, this is quality factor, and based on the quality factor it should be very high, we will be having a better tuning. So the value of R and C should be minimum in comparison with the inductance value. Okay, so then only the Q value will be very high, because Q is directly proportional to the inductance value and it is inversely proportional to the resistance and capacitance value. So the L value should be greater in comparison with the R and C values. So you can just check in each each option. In this, if you see, each option has different L and C values, so you have to check one by one which is having very high value. So if you see, I think L is having a very high value only at the fourth option, which is having 3.5. okay, so obviously that is the highest value which L is having, and when compared to the other three options, the L values are lower than the fourth one. Okay, so the L value should be more, then only you will be having a very high quality factor. So since it's directly proportional, so the correct answer is option number D. Okay, so for better tuning, the quality factor of the circuit should be very high, and the quality factor is based on the formula of 1 by R into root of L by C. So since the quality factor is directly proportional to the inductance value, in this four options, if you see, the induction value is very high for the fourth one. So the correct answer is the fourth one. Okay. So I think this video would have been useful for you to understand the basic concepts of electromagnetic induction and alternating current, and I hope we have tried to solve some sample questions which were asked in the previous year question papers, and as I said in the earlier slides, I have tried to cover I have tried to give more importance to topics like Faraday's law and Lenz law, and also AC circuits and power in AC circuits. So we are trying to give more importance to that, and as I said, you try to give more importance for these three topics, particularly Faraday's law, Lenz law, and power circuits and power in AC circuits and AC circuits. These three subtopics, if you give more importance, because for the past 8 years more than 75% of questions were coming from these three subtopics. Okay, so I wish you all a good luck for your exams. Prepare well, and thank you for watching this video.